Question 1. Rewrite x squared plus 6x plus 3 by completing the square. To do this, first of all, quadratic general form is ax squared plus bx plus c. So we can see that's the quadratic there because x to the power 2 is a 2 degree of polynomial, so it will have 2 factors, 2 roots, 1 turning point. Now, and we've been told to write it by completing the square. So what we've been told is if we get ax squared plus bx plus c, and you're transforming it by completing the square, you have to turn it into a into a bracket x plus a number which is squared plus d, where a and d are numbers. So where a and d are numbers. So what do we need to do? Well, we need to consider 2 cases. Case 1, the first case, if a equals 1. If a equals 1, then we have x squared plus bx plus c, right? And to convert that into completing the square, that means you take the x and turn the x into, just have x plus b over 2. That's what you do. And then you square it. Okay. And then you take away the square of b over 2. So that's b over 2 squared. And then you add your c. That's completing the square. That's all you do. And when you simplify this and that, you then get your d is going to be b squared, b over 2 squared minus b over 2 squared plus c, and your norm is b over 2. So that's what completing the square is if a equals 1. Case number 2, if a is not equals 1, if a is greater than 1, where you get a x squared plus bx plus c. What I need you to understand is that completing the square only affects the first 2 terms. A quadratic is a trinomial. Tri means 3. Trinomial. That means 3 terms. The first 2 terms is 3 terms, 1, 2, 3. The first 2 terms are the x squared and the x. So the completing the square only affects the first 2 terms. So what we now need to do is take the a out as a common factor. And you put a square bracket. And then you get and then to make it ready for completing the square, then you do, that's x squared, obviously if you take a out, plus b over x. So that's what we've done. We've taken a out, plus c. And now I've got a new b, and this new b, let's call it capital B, but the new b is now b over a. So now I have got a proper, to make it ready for completing the squares, I've got a x squared plus capital B x plus c. So now this is now ready for completing the square. Now what I'm now doing completing the square on is the one in the square bracket. So that's now ready. I can do completing the square on it now. Now to perform completing the square on it, all I need to do now is So my completing the square will be A. I'll take the A. And I know in the square bracket, I'll turn it just like I did here. I turn the x squared into x. So I'll turn the x squared into x. So that's x. I bring this sign along like I did here. The sign here is plus, so I bring the plus along. And now I've got a new b now, which is capital B, which is b over 2a. Don't forget my capital B. So let's write it here. Capital B is now b over a. So I have to divide that capital B by 2, which means I'm going to have b over 2a, because I'm dividing that by 2. So if I divide it by 2, that means I'm dividing this by 2, which means I'm doing b over a times 1 over 2, which is b over 2a. So that's what I've got there, b over 2a. Put in the square bracket, square it, take away the square of this b over 2a, so that will be b over 2a squared. And then you bring down the c plus c. So that's completing the square. So that's what you do. Now, if a is greater than 0, if a is greater than 1, sorry, you get, let's just roll this up so you just know where we are. Right, so that's what we've done so far. So what are the rules? So the rules are, if a is equal to 1, x, let's use this, x squared plus bx plus c will become x plus b over 2 squared minus b over 2 squared plus c. And if you have a, x squared plus bx plus c, that will become a into bracket x plus b over 2a squared minus b over 2a squared, close bracket, plus c. So that's what we need to do now. But in this case, we're only using the first one. So we're only using that's A, that's B. So we're only using the A one because A is equal to 1 here. So in this place, A equals 1. So to answer the question, now let's do the question. I will then go for x squared plus 6x plus 3 will be equal to x plus 3 squared, because I'm doing b over 2 now, right? Take away b over 2 squared, so that would be 3 squared, so that would be 9, plus c, my c is 3. And now x plus 3 squared minus 6. And that's it. That's completing square done. In fact, it's only take 2 steps, but it took a longer time to explain it. But now you know what you're doing, it'll be much quicker. So that's completing square, and that's the answer for that one. So where your d is minus 6, so that's your d is minus 6. So write it here. D is minus 6. A is equal to 1. And the number is 3. And just to remind you that this is actually, if you want to find the turning point, because that's what quadratic completing the square tells you. It tells you quickly the turning point. And the turning point for this expression that we've just done is actually, the turning point is you set this one to 0, so that'll be x plus 3 equal to 0, which implies that x equals minus 3. Now, that's the x value at the turning point. And the y value at the turning point is this here. Your d is the y value at the turning point. So your y is equal to minus 6. So if I was to sketch the graph, okay, I don't know the turning points yet. I don't know the roots yet, but I know my turning point is minus 6. So let's say that was, let's use, this was 5, 10, so that was 5, 10, so that's minus. So minus 6 is here somewhere. So that's y at minus 6 there. X is minus 3, so that's 1, 2, 3. So that's minus 3 there. So that's minus 6. Here's my turning point. That's my turning point. But I also know the intercept on the y-axis. C is the intercept on the y-axis. So intercept on the y-axis is 3. And so if that was, so that was 5. So 3 will be, so 2 makes 1. 1, 2, 3. So that'll be 3 there. So intercept on the y-axis is 3. That's my turning point. So to sketch that, it would just be, do your turning point like that, and go and meet your intercept on the y-axis, and that. So that's how you sketch it. So that's a parabola. And here, it's your turning point at, let me just write it here, at the turning point, TP, x is minus 3 and y is minus 6. That's the turning point. And that point is the point of minimum. So that's a minimum point as well. Minimum. And this is your intercept C on the y-axis. And the curve is called parabola. So it's parabola. So that's what the curve is, parabola. Right, question 2. We need to rewrite x squared minus 5x minus 1 by completing the square. Okay, the general formula is ax squared plus bx plus c. That's the standard form. And if you to rewrite it by completing the square, you've been told to do a into bracket x plus number, you square it, plus d. So that's where we're going. So x plus number, you square it, plus d. Now, a is equal to 1 in this case, b equals minus 5, and c equals minus 1. Well, that meant that this is ready for completing the square. Completing the square only affects the first 2 terms. This quadratic is trinomial. Let's go 3 times. 1, 2, 3. Tri means 3. Nomial means terms. Now, so to then write this as by completing the square, what we're meant to be doing is, if you have x squared plus bx plus c, that will become a, right, into bracket x plus b over 2. You square it, take away the square of b over 2, the square of b over 2, and then you add your c. That's your completing the square, and that's what you're meant to be doing. Right, so now let's do that. In this case, our question is x squared minus 5x minus 1. That will become, a is 1, so we don't need that. Now we turn the x squared to x. We bring this minus sign along, that's minus. we put b over 2, so that would be 5 over 2, square it, and then we take away the b over 2 squared, so that would be 5 over 2 all squared, plus c, our c is minus 1, so that's minus 1. So what would we get? X minus 5 over 2 all squared minus 25 over 4 minus 1. Now, and that still is x minus 5 over 2 all squared minus 25 over 4 minus 4 over 4. This is 1 over 1. So I'm making them the same denominator. So that means I need to multiply that by 4, multiply that by 4. And that should give me x minus 5 over 2 squared minus 29 over 4. Because they're the same denominator, I just add the numerator, which is minus 25 minus 4 is minus 29. So now I've finished with that. My x minus 5 over 2 squared. Minus 5 over 2 is my number. A is 1, so there's 1 there. And my d is minus 29 over 4. What does that tells me? Well, it tells me that. So this is the answer. We finished that actually. So that's the answer. But we can go further here. What does it tell us? Well, it tells us the turning point of the curve. Now, the turning point, 2 ways you can find the turning point of a curve. So if you want to find the turning point of a curve, you can find it in 2 ways. One, by completing the square, CTS, you can find it, or by using the formula here, which is, the formula is x equals minus b over 2a. So you can find by completing the square. In the completing the square, I need to set that one to 0. So I have to set that to 0, which means I would get x minus 5 over 2 equal to 0, and x equals to 5 over 2, which is 2.5. So that's what I'll do with completing the square. So that's how you find your x at the turning point. So this is for to find your turning point. So that's the turning point. So that's turning point. And the x at the turning point is 2.5. To find the y at the turning point, completing the square is already giving you that. This is your y at the turning point. So d is your y at the turning point. And therefore your y equals minus 29 over 4. Minus 29 divided by 4, so bring in a calculator here, turn it on, and put a fraction there, put minus 29 divided by 4, standard to decimal, minus 7.5. So that would be minus 7.25. Minus 7.25. So 2.5 is your x at the turning point, and minus 7.5 is your y. Here, b is minus 5, so that would be minus 5 over 2 times a is 1, and that gives us 5 over 2, which is 2.5. So you can see, you can also find it using the formula here, which is x equals minus b over 2a. Now, and then once you find your x, I'm afraid you have to put your x back into the formula here to find y. So you have to say y equals x squared minus 5x minus 1. and then you put your x value in there. So that would be 2.5 squared minus 5 into bracket 2.5 minus 1. And when you do that, you get your x to be minus 7.25. Your y to be minus 7.25. So that's your turning point. So that means you can go further to find your turning point. You can even go further to find your root. So we won't do that now. But let's just quickly sketch the graph just for the sake of sketching it. So here's the graph. I'm going to sketch it. Oops. Right. This is your y-axis. And that's your x-axis. So that's your x-axis. Now the equation of the y-axis is x equal to 0 because the y-axis lie at the point x equal to 0. The vertical lines are what we call the x equals to c equations. And the horizontal lines are what we called y equals to c equations. C is constant. So the equation of the x-axis is y equal to 0, and the equation of the y-axis is x equals to 0. The turning point is minus 7.5 for y and 2.5 for x. So if that was 2, 4, that would be 3. So all I could do 1, 2, 3 there, 4. 7, so I could do 5, 10. So minus 5 minus 10, that'll be 5, 10. Minus 1, minus 2. So to locate the point, x is 2.5, that's 2.5, y is minus 7.5. So 5, 6, 7.25. So that's 10, that's 7.25 there. Okay, roughly there. And so now this is your turning point, but it passes along, it cuts the y-axis at C. So that's your C, that's where it cuts the y-axis, minus 1. So your minus 1 is somewhere there where it cuts the y-axis. And so what you do is you do a turning point like that. That's your turning because it's turning. And it goes there, cuts the y-axis that way, and goes that way. So this curve is called parabola. So that's a parabola. And these are the roots that we would find later in future. So these are the roots where it crosses the x-axis. Oops, that's the C, sorry, that's the C-intercept. That's the C-intercept, and that's your root. And that's your root. So it's got two roots. And that's it. To find the roots, we just set this to 0. And then we solve it. Welcome to question 3. We need to rewrite 2x squared plus 3x minus 5 by completing the square. Okay, the general quadratic form is ax squared plus bx plus c. And if you to write it by completing the square, you've been told to do a into bracket x plus number squared plus d. A and d are numbers as well. A and d are numbers. Well, so there are always two cases in completing the square. Case 1 is a equal to 1. If a equal to 1, and case 2 is if a is greater than 1. Case 1, when a equals to 1, so you have x squared plus bx plus c, that is completing the square ready. And therefore, that will become a into bracket x plus b over 2 squared minus b over 2 squared plus c, where your d is minus b over 2 squared plus c. That's your d. Your number is b over 2. So that's what you do with completing the square. It's pretty straightforward. When a is greater than 0, that means you still have your a, x, because a is 1 squared, plus bx plus c. Now you need to, so what we have to do now is to take the a out to make it completing the square ready. So that will be, we take the a out to make it look like that. So that will be, but the completing the square only affects the first two terms. As you know, quadratic is a trinomial. That means it's got 3 terms. And the first 2 terms are the only ones that's affecting completing the square. So if I take a out of those 2 terms, I'm going to get x squared plus b over a x plus c. So all I did was take the a out. Now, I can now write my completing the square now. The a will follow when I'm writing completing the square, and c will follow. So what's ready for completing the square is the square bracket here. It's completing the square ready. So now to write my completing the square, all I have to do now is to say a x plus b over 2a. So I have to divide that by 2 now. So that's a new b. I then square it. I'll take away, I'm using this now, I'll take away the square of that one, b over 2a, so that'll be b over 2a squared, close the square bracket, and I need to add my c. And then that's basically what I need to do the completing the square. If you notice, I have got the same thing here. The a is outside, just like that one. So because the a is 1, obviously. In this case, a is not 1, so a is outside. The x plus b, the only difference is instead of b over 2, I have b over 2a. And I'm taking away b over 2a. So b over 2a, because a is not 1. If a is 1, I'll get that back. If a is 1, in fact, I don't need to put a in there. A is 1, so that's why. But if a is 1, I get the same thing back. So exactly the same thing. So all I need to do is the same thing. Just put 2a here, take a outside, put 2a there, put 2a there, and you'll see. So it's exactly the same thing. So the question I've got is 2x squared plus bx minus 5. So I can make it completing the square ready by doing that and then perform the completing the square. So let's do that. 2x squared plus 3x minus 5. And that will become, to make it completing the square ready, I will do, take the 2 out. I get x squared plus 3 over 2x, so that's completing the square ready, so I've just done that, minus 5. So I've just done exactly that. So the square bracket here is now ready for completing the square. So I'm going to perform that operation on this. And the 2 and minus 5 we just carry along. Okay, so I've got my 2 square bracket x plus 3 over 3 over, not 2, but over 4 now, because that's 2a now. So a is 2, so that would be 2 times 2 is 4. So 3 over 4 now. I don't need x anymore because there's no x there. There's no x there. So open, close square bracket, square the bracket. I need to take away the square of this. Take away the square of 3 over 4. And that will be 3 over 4 squared. Close your square bracket, so I'm closing it. I need to add minus 5, because minus 5 plus c is minus 5. And so what happened then after that? Well, I will get 2. I'll keep my square bracket, x plus 3 over 4 all squared minus 9 over 16 square bracket minus 5. So now I can carry on this side. It's actually easier, but because I'm explaining it, it's taking longer. So now I need to multiply out the square bracket. I need to remove the square bracket. So I'll get 2x plus 3 over 4 squared minus 2 times 9 is 18 divided by 16. But there's 2 on top and then a 16 below. 2 cancels the 16, so I'll get 8. So I'll get 9 over 8. Remember to multiply 2 by the numbers in the bracket, in the square bracket. And then now add in minus 5. This is minus 5 over 1. So I need to multiply that by 8 and multiply it by 8 to make it same denominator. So I get 2 into bracket x plus 3 over 4 squared minus 9 over 8 minus 40 over 8. That will be 2 into bracket x plus 3 over 4 squared minus 49 over 8. So I have finished the question then. My d is minus 49 over 8. And the number here is 3 over 4. And a is 2. Because I started with 2, so there'll be 2. The 2 just follows through. And now, so why completing the square? Well, the reason why we do completing the square is it tells us the turning point. This is the y value at the turning point. That's your y. And this one here, we have to set it to 0 and then make x equals minus 3 over 4. At the turning point, your y is minus 49 over 8. So x is minus 3 over 4, y is minus 49 over 8. How did I get minus 3 over 4? Well, because the reason I got minus 3 over 4 is because I set that to 0. So x plus 3 over 4 equal to 0. And then take away 3 over 4 on both sides. X equals minus 3 over 4. There's other ways of getting x as well, the turning point. Other ways of getting that is to use x equals minus b over 2a. I don't think you can see that, so let me write it in black. X equals minus b over 2a. We can use that formula to find the turning point. At the turning point, b is 3, so that will be minus 3 over 2 times a. A is 2. A is 2, so therefore I would have 4. 2 times a is 4. There we go. So x is minus 3 over 4. So that's another way of finding a turning point. And then you have to substitute that x into that equation here. So you have to say y equals x squared, 2x squared, plus 3x minus 5. If you substitute the x into there and into there, you get your y to be minus 49 over 8. So that's how you can find a turning point without completing the square. But with completing the square tells you the turning point, and the y value is your d, and your x is you set that to 0, x will become minus 3 over 4 in this case. Let's quickly sketch the graph. We're not told to sketch, but I'm just sketching. Sketching the graph is pretty quick. I know we don't know the roots yet. To find the roots, we just set this to 0 and we solve. But let's not do that. Minus 3 over 4. So if I do that, it says minus 3 divided by 4. And that's equals to 0.75. So that's minus 0.75. So x is, if this is 1, minus 1, minus 2, minus 0.75 is somewhere there. So that's your x. And y is minus 49 over 8. So 49 divided by 8, 6.125. So y is minus 6.125. So that was, let's say that was 5, 10, minus 5. So x is minus 0.75 and minus 6. So this is your turning point here. So that's your x at the turning point, and that's your y at the turning point. So the turning point passes through minus 5 because the intercept, c is the intercept on the y-axis. So it will go like that. So it's pretty close there. Here we go, and here we go like that. So that's the parabola here. So this curve is parabola. That curve is parabola. Those points here will be your root if we calculated them. That's your root or solutions. Solution. And that's the second root. Solution or root. That's another name for it. Your turning point here, TP, coordinates minus 3 over 4, comma, minus 49 over 8. And that's the minimum value as well, because it's a minimum. The curve is minimum. It's minimum because A is positive. A is positive, that's why it's minimum. If it's negative, it will be N shape. It will be maximum.